find the measure of each acute interior angle of a regular pentagram, as well as each reflex interior angle of the pentagram. So a pentagram, what are they talking about here? They're talking about polygrams. A pentagram is a polygram. And we learned that a polygram is a polygon that you can create using any convex polygon with 5 or more sides. And you create the polygram by extending the sides of the convex polygon until they intersect. And those intersection points are the vertices of the new polygon, the polygram. Okay, you can do this with any convex polygon. It doesn't have to be regular. But here they're referring to a regular polygon, specifically a regular pentagram. So a polygram created using a regular pentagon. So if we take a look at a regular pentagram, we can see the associated regular pentagon in the center here. And what they've done is you can see they extend the sides until they intersect, and these intersection points are the vertices of the new polygon. So technically, this polygon, if we want to look at the technical pentagram here, these aren't sides. They just, a lot of times they'll leave the interior polygon, but these aren't sides. This is the new polygon. This is the polygram here. And you can see the polygram is a concave polygon because some of its interior angles are reflex. Okay, so the interior angles of this polygon are, here's the acute interior angles that they're referring to, and here's the reflex interior angles that make this concave. That's what they're talking about. Okay, now if you have a regular polygram, all of the acute angles are going to be congruent, and all the reflex angles are going to be congruent to each other. And in addition to that, all of the side lengths are going to be congruent. Okay, so with that, can we find the measure of each of the acute interior angles as well as the reflex interior angles? Well, okay, what we can do is we can start by, we have the relation that gives the sum of all of the angles, the interior angles of a polygon based on the number of sides. So we know that is S is equal to n minus 2 times 180. Okay, well, we can see this polygon here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So you have 10 minus 2 is 8 times 180. So 1,440. Okay, that's some useful information to start. Okay, and so let's go ahead and put the interior pentagon back, because we might be able to use this as a reference. So we know, like, this angle here, all of these angles are going to be, let's see, that would be 5 minus 2 times 180 and then divided by 5, right? The interior angles of a regular polygon. So 3/5 times 180 is 108 degrees. So that is I. Okay, now let's see. We can do, so we'll call this R for reflex, and we'll call this A for acute. So we've got 1, 2, 3, 4, 5 acute angles, and then we've got 1, 2, 3, 4, 5 reflex angles, and those are going to sum to 1440. So we can factor out a 5 here. So A plus R is equal to 288. Okay. Now, let's see. We know that these two, all the sides are congruent, but we weren't told anything about like if this side length of the interior pentagon is congruent to those two sides. So, okay, but we do know information about exterior angles of a polygon, and these are exterior angles of this interior pentagon, right? We know, for example, that this angle and this angle are supplementary. So we can get these angles here, which are all going to be the same. Okay, so let's do that. We can, because it's going to be 180 minus 108. So this is going to be 72 degrees. All of these angles, this is going to be 72. All of these are going to be 72. This is 72. This is 72. So we can go ahead and get the acute angle because we're going to have 72 times 2 is 144. Now 180 minus 144 is going to be A. $36. Okay, but now we've got this formula here. So R is equal to 288 minus 36. $252. And there we go. And a okay, here we've got the same question except with a regular octagram. So here is a regular octagram, and you can see the interior octagon here and how all of the sides have been extended, and where they intersect creates the vertices of the new polygon, the polygram. Okay, and we can more clearly see the octagram if we erase this the interior polygon. So there's the octagram, the regular octagram. Okay, so let's put the interior octagon back in, but make it not as bold. Okay, so let's see. We've got each of these interior angles. We've got the reflex angles, and then we've got the acute angles. So let's just start by getting the sum of all the interior angles of this octagram here. So we're going to have n minus 2 times 180. So how many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sides. So it's going to be 14 times 180. $2,520 degrees. Okay, so this is A, this is the reflex, and this is I. So let's get I. The interior angles, the measure of the interior angles of a octagon. So we've got, so it's going to be n minus 2 times 180 over n. So there's 8 sides to an octagon, so this is 3/4 times 180. So 180 divided by 4 is 45. 45 times 3 is 135. So I is equal to 135 degrees. Okay, so now we can use the fact that these exterior angles here are going to be supplementary to I. So what is 180 minus 135? Well, that's going to be 45. So this is 45. So now we can get A because it's going to be, these two angles are equal, right? For sure. And so in that case, we've got 45 plus 45 is 90, then 180 minus 90. So, okay, these are right triangles. A is equal to 90. Cool. Okay, but now we can use the formula for, we can say, okay, how many reflex angles are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 reflex angles, plus there should be 8 acute angles. 1, 2, 3, 4, 5, 6, 7, okay? Plus 8 acute angles is going to be equal to 25, 20. So we factor out in 8 and divide by 8. You get 315. So the measure of the reflex angles is 315 minus 90. 225. Consider any regular polygon. Find and join in order the midpoints of the sides. What does intuition tell you about the resulting polygon? All right, so let's take a regular hexagon. All right, now let's join the midpoints of the sides. Okay, what does intuition tell you about the resulting polygon? Well, it looks like it's another regular hexagon for sure, but maybe just a little bit smaller, just scaled down a little bit. Consider a regular hexagon, RSTUVW. What does intuition tell you about triangle RTV, the result of drawing diagonals between those vertices? So, okay. We've got this hexagon, regular hexagon here, and so let's put the vertices. We have to honor the order. Okay, so now with that, let's draw RT, segment RT, segment TV, and segment VR. Okay, so what does intuition tell us about this triangle here, RTV? Well, it looks like it's going to be equilateral, I would say. It seems like all of these sides are of the same length. That's what I would say. The face of a clock has the shape of a regular polygon with 12 sides. Okay, so what is the measure of the angle formed by 2 consecutive sides? Well, this is just going to be whatever the interior angle measure is. And since this polygon is regular, then all of these are going to have, these interior angles are going to be the same measure. So we just need to find what is the interior angle of a polygon, of a regular polygon, the interior angle measure of a regular polygon with 12 sides. Well, we know it's n minus 2 times 180 degrees divided by n. In this case, we've got n is equal to 2, or n is equal to 12. So we have 10 twelfths times 180, so 10 divided by 2. Okay, 30 times 6 is 180, and then 30 times 5 is 150. So this is 150 degrees. The top surface of a picnic table is in the shape of a regular hexagon. What is the measure of the angle formed by 2 consecutive sides? Same thing. Easy. We've got this n. It's a regular hexagon. N minus 2 times 180 over n. But in this case, n is equal to 6. 6 minus 2 is 4. Okay. 3 times 60 is 180. So we've got 120 degrees. For the concave quadrilateral ABCD, explain why the sum of the interior angles is 360 degrees. That's part A, and then part B. This is part B. We'll come to part B in a second. So we know that the sum of the interior angles of any polygon is given by this formula. Any polygon, convex or concave. And so any quadrilateral convex or concave, based on this formula, the sum is going to be 360 of the interior angles. So, but the reason why they're asking us this is that we went through a proof for the sum of the interior angles for convex polygons, but we didn't really do this with concave polygons. So let's see if we can explain why the sum of these interior angles is going to be 360. And maybe we can do the same type of method that we used with convex polygons. So we can draw a diagonal here. Now we've got these two triangles. Okay, so let's see. We've got let's call this angle 1, this angle 2, this angle 3, and this angle 4. So with that, then, we can say that the measure of angle A plus the measure of angle 1 plus the measure of angle 2, that's going to be 180, right? Okay, and now we can also say that the measure of angle C plus the measure of angle 3 plus the measure of angle 4 is also 180. So if we add these two equations, we get the measure of angle A plus the measure of angle C plus the measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 plus the measure of angle 4 is equal to 180 plus 180 is 360. Now, we can continue to simplify because we've got the measure of angle 1 plus the measure of angle 3 is the measure of angle B, and the measure of angle 2 plus the measure of angle 4 is the measure of angle D. And there you go. So we actually could use the exact same type of proof in regards to concave polygons as well, to prove that the sum of the interior angles of any polygon, concave or convex, is equal to that formula. You just break it up into triangles. Okay, now the second part, if the measure of angle A is 20 degrees, the measure of angle B or measure of angle C is 31, measure of angle B is 88, then what's the reflex angle measure? Okay, well, there we go. So 20 plus 31 plus 88, 360 minus is 221. There we go. So now we know that, again, this method here of breaking up the polygon into triangles, this applies to any kind of polygon, concave or complex, as far as the summing all the interior angles. Is it possible for a polygon to have the following sum of measures for its interior angles? 600 or 720. So, okay, well, let's get the formula for the sum of the interior angles of any polygon. Okay, so, yeah, what we're going to want to do here is just, we need to get an integer value for n, or else it doesn't make sense, right? So that's what they're going for here. So we can, part A, if could 600 be a possibility for the sum of the interior angles of a polygon? Well, okay, well, we just need to, if n's not an integer, then no. So no. Okay. 720. Four. So yes, this would be a six-sided polygon, convex or concave. Yes. Draw a concave hexagon that has, so one interior reflex angle. Let's start with that. So they're not saying regular or anything. Well, it can't, a concave polygon can't be regular. So, all right, well, let's just draw. There's the reflex angle. Now we need six sides. So we need four more sides. 1, 2, 3, 4. This isn't a reflex angle. This is just obtuse, right? 1, 2, 3, 4, 5, 6. And there's the one reflex angle. There we go. Okay. Part B. Let's see. We have two reflex angles now, but also a hexagon. So, okay, we could do this. We could do 1, 2, 3, 4, 5, 6, like this, like an hourglass shape. At least the cross section of an hourglass. Yeah, there you go. There's two reflex angles, six sides. Okay, draw a concave pentagon. So same question, but with a pentagon. This is interesting. Okay, so here's the reflex angle, and now we need three more sides. 1, 2, 3. And then one reflex angle. There we go. Okay. Let's see. Now two reflex angles. Okay. So one. Okay. How are we going to do this? So one would be. So maybe you need to have them consecutive. Let's see. There's a reflex angle. I mean, can you do, is this possible? So, okay, wait a minute. The sum of the interior angles of a pentagon is going to be, so n minus 2 times 180, that's 3 times 180. 540. So reflex angles are going to be greater than 180. So what that means is that all you're going to have left, at best, all you're going to have left for the other three interior angles is going to be, if we subtract 360 from 540, 180. So I guess you could do that. 180 divided by 3, it's like each one is 60 degrees. So, okay. Maybe like this. Yeah, there we go. Okay. There you go. 1, 2, 3, 4, 5, and there's two reflex angles. For concave pentagon ABCDE, find the measure of the reflex angle at vertex E if the measure of angle A is equal to the measure of angle D is equal to X. Measure of angle B is equal to measure of angle C is equal to 2X. And the measure of angle E is equal to 4X. Okay, so what we just saw that any pentagon, the sum of its interior angles is going to be 540 degrees. So, I mean, yeah, you just add all this up. X plus 2X plus 2X plus 4X is equal to 540. So let's solve for X, but then what they're asking for is the measure of E. So we'll have to come back and multiply the X by 4. But, okay, 4, 5, 6, 7, 8, 9, 10. So 10X is equal to 540. 54. Okay, but what they're looking for, though, is they want this, the measure of the reflex angle. So 54 times 4, 5 times 4 is 20, 21. So measure of angle E is equal to 216 degrees. For concave hexagon, HJKLMN, the measure of angle H is equal to Y, and the measure of the reflex angle at N is equal to 2 times Y plus 10. Find the measure of the interior angle at vertex N. So yeah, if we can find Y, we can get N. So we can see that the congruences here, these are all congruent, and K is congruent to N. So, okay, this is a hexagon, so the sum of the interior angles is going to be 6 minus 2 is 4. 4 times 180 is 720. Okay. So with that, then we've got y plus y plus y plus y is 4y. And if we take 2 of these, 2 times y plus 10s, that's going to be 4 times y plus 10. This needs to add to 720. So 4y plus 40 is equal to 720. 8y is equal to 720 minus 40 is 680. So we've got 8 times 8 is 64. 8 times 5 is 40. So y is equal to 85 degrees. Okay, but they want the measure of N and K here. So that's going to be 2 times y plus 10. Y plus 10 is 95. So the measure of angle N is 95 times 2 is 190.